I'm going to honor your time and stay within the constraints of my time up here. And what I will promise you is we're going to have a little fun, and we're going to be talking about Gen AI, we're going to be talking about quantum, and we're going to be talking about AGI. So we're going to define some terms. I will advise you there will be no formulas. Okay, I'm kind of a nerd, but I'm not that level of a nerd, all right? And I'm going to tell you a little story to start out with, and I'm going to tie this story at the end of this presentation, so you'll want to pay attention, because there's a little bit of a cliffhanger here I'm going to set up for you. January 18th, 2023 was day 2 of the Qubits conference in Miami, Florida. At that conference, aside from Alan and his presentation, which had a lot of costume changes, which we enjoyed, we were able to present our work at one of the ports on the West Coast. And also on the 18th was a fellow by the name of David Pogue, a reporter, a writer, an entertainer, and he gave a keynote on disruptive technologies over the next 5 years. To include, of course, quantum, and he spent a good amount of time on Gen AI. And we'd been working at SavantX on Gen AI for some time prior to that. Training models, working this, large language models, open source models, and with keen attention to creating some capabilities. But it was David Pogue's presentation at Qubits that really was a pivot point for us. So I want to remind you that you're here and you're watching these presentations, you're soaking in all this information, these use cases that are being manifested in the real world with real KPIs that are being met, and good business reasons for applying quantum and using the D-Wave. But what isn't readily apparent, perhaps, is this notion that during the breaks, at the clam bake, other times when you're meeting your compadres here, your new friends, and you're having discussions, you never know where there'll be a gem of an idea that you will be able to cross and to expand on. So for me, it was David Pogue. And this brings us to today, when Alan and the team reached out and said, Ed, would you be so kind as to consider coming Qubits 2024? I'm like, well, you saw what happened in 2023. You really want me back in 2024? And they said, yeah, this would be great. And they wanted me to talk about some of the other things that we're doing. And those other things that we're doing are really around the area of, well, there's some use cases that I'll be talking about. And I'm just going to touch upon those. And while they're interesting, they're not quantum AGI. And for us in this presentation, what I'm going to lay out for you is we are on a flight plan to create quantum AGI. This little company called SavantX, we've been around since 2015. We've got a fantastic team together. Folks out of Los Alamos Lab. We have a research center in Santa Fe, New Mexico. Just phenomenal folks. And we also utilize Gen AI. And I'll talk a little bit about that as well. So we have been working with quantum for 5 years now, at least. We have been working to come up with this notion of bringing Gen AI into an operational construct so that you can actually make some use out of it. And I'll give you examples of that. And we're going to lay out this path of how we're getting there in sort of these bite-sized chunks with a live demo. And anybody here, does anybody care about, do you like true crime sort of things? Anybody into that? A few people? One person? One person. It's kind of a popular genre. So we actually have been running a product we call Seeker with law enforcement. We started beta testing last summer. And out of all this, it was very cool. We ended up with detectives that didn't know how to spell AI that are using Seeker, that are using it in ways that we could not imagine, that have actually, we had a cold case that they were playing with as sort of a test bed. And I got a call not too long ago from this detective, and he said, Ed, you know, we're going to demo this cold case to a bunch of sheriffs and police chiefs, and we can't do it. I'm like, what do you mean we can't do it? He said, well, we're opening the case up. This is a case that's over 20 years old, and the reason they're opening it is because Seeker. So think two product lines, think Hone and think Seeker. And Hone is heavily classical optimization with quantum, and then Seeker is Gen AI. And it's ChatGPT for your own content. Think of it that way. And that is the foundation that we're using to build quantum AGI. And I'll explain why it's so important that we're able to apply quantum to create AGI. So one thing I want to do right now, and by the way, we're going to get to one final slide. There's like 10 slides, so I'm not going to, you know, pelter you with slides here. But there's going to be one little summary slide that you'll want to pay close attention to, and then I'll wrap up something that David Pogue told me last January 18th that was really underscored this pivot for us. So what I'm going to do right now, if we can switch over to my laptop, please. We're going to run with scissors. We're going to do a live demo, and to get to this live demo, what we're simply going to do here is we are going to do this. Yeah, okay. Do a presentation, and yeah, here we go. I'm going to show you this. So we're going to drop this file in right now. We're going to ingest it into sort of a deprecated Seeker so that we can demonstrate something called quantum prompt optimization, and we'll tell you why that's kind of an important thing. So let's do this. So we're going to go, and here we go back to here. We're going to go select, and we're going to select a file, and we're going to take in this DCI. Is that right? Yeah, DCI reports. We're going to go ahead and we're going to ingest that. So we'll come back to this now. Let's go back to the slides, please. And we're going to finish up. I don't think we're going to have time for Q&A. Catch me at the clam bake. All right. So SavantX, we've been first in now 3 quantum first. All right. The first was intermodal transportation, Port of LA. We applied the D-Wave to appointing trucks to cranes. Demonstrable benefit from that. I love this morning that, you know, everyone's trying to decide, is it quantum advantage, is it quantum supremacy? We're pretty pragmatic. We look at it and say, can we take the D-Wave and can we apply it in a way that provides value to the customer? And in the case of the port, and we're moving this into other ports now, the answer is yes. And that was appointing trucks to cranes. So a problem that on an HPC, high-performance computing cluster, would take months, we were doing it in, I should know this, 15-second round trip, hitting the D-Wave. Amazing stuff. So second, in fact, when D-Wave called and asked me to come and present, they said, hey, why don't you talk about what you're doing with the Air Force and Air Mobility Command? I said, well, I can. And that's an ongoing project. We're in phase 2, going to phase 3. We've yielded over a 40% increase in network efficiency using the D-Wave with our own Qubits. And I said, I can do that, but that's not the future for us. The future for SavantX is quantum AGI. Okay, we're really excited about this, if you haven't noticed. And then today, we're actually going to demonstrate QPO applying quantum into Gen AI. It's one of a whole pull-down menu of steps, and I'll go through at the 50,000-foot level. We're not going to share the company secrets, the Coke formula here, but we are going to show our path, our trajectory, our ascent to quantum AGI, and why quantum AGI is, we believe, the path to AGI. So let's go ahead and let's talk a little bit about what is AGI. So lots of definitions. I think Elon Musk's latest definition is one that I personally subscribe to, and that is an AI that's smarter than the smartest human on the planet. You can guess whatever that IQ number is. I would even suggest that ChatGPT 4.0 is already at a level of AGI. US average IQ is 97, Hong Kong's 106. It's ratcheting it up. Every few weeks, I would say we're gaining a couple of IQ points in terms of large language models. But we're on a trajectory right now. Microsoft is committed to something called Stargate. Stargate is a $100 to $110 billion initiative to build the world's largest supercomputer across a number of locations. It's going to require, they plan to build it in 6 years, and it's going to require 5 gigawatts, again, 5 gigawatts of energy to power that sucker. And it'll be used for training models and for inferencing. People kind of confuse all this, but if you're going to train a model like ChatGPT 4.0, estimates are they spend about $250 million to train the first version of 4.0. And most of that, 90, 95%, some say, was just for the energy costs. But once you've trained the model, then to use it, let's call it inferencing, you can use it on lower horsepower hardware, as it were, for inferencing, and you can provide that, when you're on ChatGPT, it's inferencing, you're not training anything. But high energy requirements. So where quantum comes in and where we see really distinct advantages, and these advantages we have agonized over identifying them, validating them, and racking and stacking, and then applying a process to get to AGI, artificial general intelligence, smarter than the smartest person on the planet. And that is being able to come up with new algorithms that address some of the inefficiencies out there. Quantum is great for that. We have to get through massive libraries of knowledge. Right now, the race to AGI, and there will be many AGIs, the question is, will you be able to have access to one of those AGIs? Is it going to cost $1 million for a prompt? I don't know. But I do know that we're on this trajectory where they're just building bigger and bigger and bigger models because that's what they can do. And they look at this, and it's a trajectory that that's predictive, that they can, with assurance, invest in. Where that model changes is anyone's guess. We're looking at it saying, hey, listen, let those guys keep making better models. There's a great open source community. Let's instead of focusing on the large language model, let's focus on the content. Organizations, businesses, government has content. These models have been trained up on the internet. What does that mean? About 3% of the internet is indexed by Google. 3%. Okay? It's a lot out there that hasn't been indexed. Organizationally, that's where the gold mine of knowledge is. And that's where any organization, if you can take your knowledge, your content, your data, turn it into accessible knowledge rapidly with validation, verification, and trustworthiness, and with insight and reasoning, and to understand things like what are facts, what are observations, right? What are concepts? What's speculation? Those kinds of things. If you can understand your data at those levels and have a large language model reason it, then you're sitting on a gold mine. And that's what we're looking at. We are data first and using quantum to get to that. So the energy cost to scale out quantum AGI, or to scale out AGI in the current path of classical, is prohibitive from an energy standpoint and cost standpoint, in our humble opinion. So we have, we've also, it's model-centric or knowledge-centric. So we're on the knowledge-centric side, powering it with quantum. So there's this thing called Seeker, and we're going to actually use a deprecated version of it to demonstrate quantum prompt optimization against this cold case today. And we'll do that briefly here in a minute. And what's really cool about think of the approach is they call them RAG models. I didn't even know we had a RAG model till last summer. It stands for Retrieval Augmented Generation. What does that mean? That means you have essentially a search engine to go after your content, your organization's content, get the results back. So you type in, like you would in ChatGPT, I need some insight on XYZ. That creates a search across your content with the Seeker stack results come back, and then it's fed into the context window, and you get this nice response, and then you're able to click and validate. And I'll demonstrate that. So we've spent years building this, and this has been separate from any quantum efforts and desires. And to be honest with you, we've been doing it a long time. Many years. We've got 4, I think we're actually 5 patents on the technology now. And we've got thousands of people using it, and we've found gravity's pulling us into law enforcement, interestingly enough, and then also to the IC in terms of air gap deployments that are secure. It's quite fascinating to find the use cases. Let's see here. So I'm going to get to just a quick overview of, so Seeker, it's today. We went live the end of last year with it. And we're using it as a foundation, a workbench, if you will, where the users are helping us iterate it. And what we're building in parallel is something called Quinn that has a stack of quantum processes. And then on top of that is sort of the brass ring, something we call QuinnStar. And that's where the magic, the learning happens. I won't talk a lot about that today because, to be honest with you, I don't really understand what we're doing there. We've got some really brilliant people. We have one individual who's leading that team. He basically worked this up on the black side some years ago, constrained with classical compute, and now all bets are off. The doors are wide open with quantum. So he's very excited. Him and the team are very excited about that. So we're going from Seeker, we're building Quinn this year, and then something called QuinnStar next year that'll have a quantum-powered reasoning. There's something that's really kind of cool is, we actually have, we call it quantum dreaming. So think of ChatGPT that's interrogative, that will learn your intent to understand things, and then it'll have goal seeking, and it will think about things. So it's like, I could be working with Quinn, with QuinnStar, trying to solve some problems and having it work, and it'll come back with some recommendations. And then I may say, go ahead and do those recommendations. And then later, it'll come back, it'll think about what our conversation, it'll go back and look at the data again, and it'll come back with other ideas. It's like, maybe we should have done this. No, I don't know. But having that ability to reflect is really important, and we see the only way to do that is through quantum. And what's fascinating is we have racked and stacked this into optimization routines. So it's sort of like if you're a hammer, everything's a nail. Well, we have the D-Wave, and we know how to just optimize the heck out of things. So we look at the world as one big optimization problem, and we split it up into bite-sized chunks. And it's a process that has proven to be very valuable and fruitful for us. So this is kind of the most complicated slide of the day. So on the left is Seeker, a current stack. Again, this 50,000 foot. That translates over into Quinn, and then there are 6 processes there that are quantum-centric. And the lower right, or not quite all the way down, is something called QPO, Quantum Prompt Optimization. And that's what we're going to look at today here. But all these discrete processes that we enable from a quantum standpoint give us the ability to, again, rapidly find the right knowledge and make it available to the large language model. And we're talking about our benchmark is 100 million files that we need to be able to go out to in sub-1 second timing and make it available to the large language model. And because if you think about it, if you want a AGI, if you want an artificial general intelligence, general means it has to have access to massive repositories of knowledge. And you can't just train that into these models. It's a point of diminishing returns there. There's issues around hallucination, et cetera, trustworthiness, verification, validation, citations, and all this. So by racking and stacking this with quantum, you get past all those barriers. So now we're going to here in a second go to the cold case, and I'm just going to show you real quick here. Again, this is a real case. The locations, names have been changed. It was late 90s this came up, been unsolved all these years. I've had the good fortune of working with a detective that this was one of his first cases when he came on the force, before he was a detective. So it's near and dear to his heart. let's see, what else do we need to know? There's this individual, there's a homicide, an individual by the name of Crawford was found with a gunshot wound apparent gunshot wound to the head. That's even a little fuzzy. So this is unsolved, but it's now been reopened. So if we can switch over, please, to my laptop here. Okay, excellent. So this is Seeker. Again, this is a deprecated version that we can demo this cold case on, because this is actually lives in the Quinn stack we're building, which we started on early this year. So this is the file that I just ingested here. It went out to the D-Wave, and we actually ran it against, we did our stack of processes on the ingest, tokenization, et cetera. Then it went to the D-Wave, and it created, part of what that process is on this content. In fact, let me show you this content real quick. I'll give you guys a little bit more of a, this is what this document I just uploaded and ingested, and we ran against the D-Wave. It's like 57 pages. And what we did is we had another LLM look at this, chunk it out, quantize it, and create prompts against each of those chunks, all right? And then the D-Wave looks at 3 constraints. In total, I think there's a couple hundred prompts probably on this that were just generated. And then what the D-Wave does is it optimizes against 3 constraints, those prompts based on wherever you're at in terms of chunks of that content that come up during the chat. I'm not sure that's probably the best explanation, but that is what happens. So here we go. I'm just going to give you an example. So here's 3 prompts relative to that. Let's go back and let's add another document. And those 3 prompts are suggested quantum prompt suggestions. We have a few more to go from. And then let's go back here and we'll add the final document here. So we're looking at, there's 1,225 pages of content now that have been optimized, and these prompts that have been generated. And in fact, I'm actually going to start out here, and I'm going to say, I don't like doing public typing, so bear with me. Thankfully, LLMs are very forgiving of misspellings. So what I'm going to say here is provide, we'll misspell it in it. Provide an investigative overview of this case. We're going to use, we'll use 4.0 here. We have our own model as well, but for this today. So I didn't use any of the suggested prompts, but I wanted you to see we'll start out. You don't have to use the suggested prompts given where you're at in this content, but so you could put anything in you want. It's going to give us a response here. It's going to give us a little bit of an overview of the homicide, who was involved, multiple agencies, et cetera. And then we can come up here, and then we can take a role. It's really fascinating, the detectives and how they work this, but we'll just take, here's one of the optimized prompts through the D-Wave. And then, so it'll give us a response here. And I'm going to show you, I'll show you 2 tabs here very quickly, then we're going to roll back to the slides. And what's kind of cool about all this is, and with Seeker, because of the nature of our RAG model here, retrieval augmented generation, we can go here and we can see exactly where the content was identified and derived and pushed into the context window. So we have a full audit trail to get to that nice conversational response, which you need in a court of law, lo and behold. Who would have thunk? And what's kind of fun here too, we'll just go to the inspect. Here's another way of looking at this. This is basically an automated link analysis tool. So let's go back to the slides, please. I'm dangerously low on time here. So here's a block diagram. How's that for a little nerdiness? But this kind of shows what's going on here and how those prompts, all these prompts are generated with the LLM, and then they are optimized across 3 constraints, and then they are served up as needed as you're interrogating the content. This is to wrap this up, it's kind of cool. You got a small document, these are kind of notional. We can get these values way down, but 15 seconds here on the stage today to get this, do the round trip. A medium document, it's 15 seconds. It would take days classically to do this sort of optimization. A large document literally would take years. It still takes us 15 seconds on the D-Wave. Those are the kind of metrics that are important to us. Those are the kind of metrics that we can bake into and are baking into quantum AGI, taking Seeker to Quinn and Quinn-Star. And then the last, I promised you to close this out, back to David Pogue a year and a half ago, after he gave his presentation, and I was very intrigued with his talk about Gen AI and ChatGPT. He was talking about ChatGPT 3.5 that had only been out since the prior November. As you may recall, came out, I think it was November 20th in 2022, sort of day zero. I was talking to him before we had to run off and catch a flight. And, you know, what do you know about what's coming next, et cetera? He says, Ed, he said, I have friends at ChatGPT. I have not played with this, but they are working on 4. They are actually testing 4. And it was described to me that 4.0 was like looking at the face of God, okay? And we can play with 4.0 now. I don't know about looking at the face of God, but it struck me really quite dramatically. And that really stayed with me. And then as we move forward, we developed Seeker, and then we went through this exercise of, could we make quantum AGI? And what would that look like? Could we do it with a D-Wave? Could we do it with a D-Wave today? And the answers were yes and yes. And we said, let's do it. So we started on this project in January this year. So by the end of this year, first 12 months, is that right? Actually, 12 months from now, we'll have Quinn, and then the next 12 months, we'll have Quinn-Star. So it's a very exciting time for us. I hope you have the opportunity to keep everybody apprised on this as we move forward. But what's important is we're working on AGI so that it's practical so that organizations can afford it and deploy it and use it and derive value. If we and others don't do this kind of thing, there's going to be many AGIs, but if you're relying on the OpenAIs and the Anthropics, Microsoft, and Googles of the world to create AGI, God bless us all, because the control around that and the access around that is going to be severely limited for obvious reasons and less obvious reasons, I believe. So it is not going to be a capability that we generally will be able to benefit from. Those corporations will benefit from it. Nation states will benefit from it. But what about the rest of us? What about the rest of us that have organizations and companies and desires to take things to the next level? And AGI and quantum AGI is how we get there. That is our belief, and we're committed to it. And I really thank everybody so much for your time today. And also I want to give a shout out to the professionalism of the D-Wave team has been awesome, and also the AV team. These are like the unsung heroes. So a round of applause for everybody on that, please.